All right, today we're going to be looking at how quadratics transform, or transformations of quadratics. This is going to be similar to what you learned in 7th grade pre-AP when you did rotations and shifts and reflections. It's going to be similar to that. And quadratics are really the easiest way to see how that works. Again, we're going to start with translations. Remember, a translation is a shift in the position of a figure, either up, down, left, or right. So we're not changing the figure at all, we're just moving the figure. Adding or subtracting integers in the equations of functions translates the graphs of the functions. Okay, again, or I guess not again, but what we're going to be doing is we're going to be looking at the original, or the parent function. A parent function is the most basic function of a quadratic, which is just simply x squared. So if you look here, it says the graph of g of x equals x squared plus k is the graph of f of x equals x squared when it's been translated vertically. So that k at the end after the square translates a graph vertically. Okay, if the number after the exponent, the plus 8, is a positive number, that is going to go up 8 units. So wherever x squared would graph, 8 units higher would be x squared plus 8. In the opposite of that, x squared minus 6 would be down 6 units. So that graph would move down from x squared. You would look down 6 spots on the y-axis, and you would find the vertex for that. Okay, again, our next one, the next type of shift rather than a vertical shift would be a horizontal shift, or a horizontal translation. The graph of g of x equals x minus h all squared is the graph of f of x equals x squared translated horizontally. A key thing here to note is really this minus h right here that you're going to see. It's really important that we see that it is a minus h, which means that the number in parentheses is going to do the opposite of what would seem logical. So really, this minus 2 is really a positive 2. So this is, it's right 2 units, because the equation says the opposite of h. So since we have negative 2, it's going to go right 2 units. And on our second one, p of x, where it says x plus 10, that's going to go left 10 units. Okay, so that would be just simple. If I were to do a vertical translation, it would be the plus or minus after the square, and that goes with logic. Plus 8 is up 8, minus 6 is down 6. To do a horizontal translation, that's inside parentheses, and if it's a minus, it goes to the right, and a plus goes to the left. All right, the graph of g of x equals x minus h all squared plus k is the parent function x squared translated both vertically and horizontally. Excuse me. The coordinate hk is now the vertex of the new function. So pulling out the number that would be where h is and the number where k is would be the new vertex when it's written in this form. So if we look at our first one, it says g of x equals x plus 1 all squared plus 7. So I'm going to look first at the horizontal translation. Because it says plus 1, I know that it's going to go left 1, and because it's plus 7, it's going to go up 7. Since it goes left 1, the opposite of a positive 1 for our vertex would be a negative 1, and then up 7 would be a positive 7. So since we're going left, it's negative 1, 7 as our new vertex. All right, looking at B, because it says minus 2, I know that that is right 2, and then plus 5 would be up 5. So since we're going right 2, up 5, our new vertex would be 2, 5. All right, on C, x minus 3 all squared minus 8 means that we're going right 3, and we're going down 8. That minus 8 on the end means down 8 units. So my new vertex would be 3, comma, negative 8. All right, on my last one, it's x plus 4 all squared minus 1. So that is left 4 and down 1. So that would be negative 4, negative 1. All right, for our example, it says describe how the graph of each function is related to the graph of f of x equals x squared. Well, if you look, they've given us here on the bottom, this function is x squared, and then g of x is our new function right here. So if you look, what happened was that graph went up 4 units. Okay, again, looking on the second one on B, this is our original here, the one that has the blue arrow. The red arrow is our new one. Again, it moved 1, 2, 3 left. And it's going left 3 units. And again, that's the opposite of what we see in the parentheses. Plus 3 would normally make us think right 3, but it means left 3 units. All right, I want you to go down to the bottom, and I want you to practice those 9, and then you can submit those to your teacher to make sure that you have those correct. All right, let's move on to the next set. Our next set are our dilations and our reflections. Excuse me. A dilation is a transformation that makes the graph narrower, which means it's vertically stretched, or wider, which is sometimes called a vertical compression, or sometimes is called a horizontal stretch compared to the parent graph. A reflection flips a figure across the x-axis. All right, I want you to look over here on the right. I'm gonna outline the parent function in red here. This is our parent function, the one that says a equals 1. That parent function is the original or the most basic function. F of x equals x squared. And then if you'll notice, it says when a is greater than 1, that's what we call a vertical stretch. So our vertical stretch here would be represented by the graph that's now blue. So that would be our vertical stretch. If you notice, the graph is narrower than the original. A horizontal stretch or a vertical compression, and again, our tests have been focused on using the term horizontal stretch more than a vertical compression, but a horizontal stretch makes the graph wider than it originally was. And if you look, it says to be a vertical stretch that a has to be greater than 1. To be a horizontal stretch, the a needs to be between 0 and 1. Okay, so if I look at my two examples, I've got f of x equals ax squared. It says it stretches or compresses the graph. So that 2/3 x squared would be what we call a horizontal stretch because that number is smaller than 1. Okay, a vertical stretch would be like 5x squared. So that would be our vertical stretch, the blue. Okay, and then it says the graph of the function negative f of x reflects the graph of f of x equals x squared across the y-axis. So to be a reflection, it doesn't matter what the number is. That can be a second part. But if you look here, that negative in front of both of these makes it a reflection. So this is a reflected, and I'm going to abbreviate that, reflected, and then it becomes a vertical stretch. Over here we have a reflected, and again I'm going to abbreviate it, reflected. Then we'd have a horizontal stretch because that number is smaller than 1. All right. Again, looking at this, we've got our original is f of x equals x squared. Our new is f of x equals 2x squared. And so because that number right here in the front is greater than 1, we have a vertical stretch. Okay, and if you notice on a vertical stretch alone, the graph does not change vertex. The vertex remains the same. And even on a reflection, the vertex does not change. So if we only have a vertical stretch or a horizontal stretch, or we only have a stretch and a reflection, it does not change the location of our vertex. All right, let's look at B. So on B, we have a couple different things. Number one, we have a reflection. Okay. Number two, we have a horizontal stretch. Again, that horizontal stretch comes from the 1/2. And then we have a shift of down 3 units. And again, you could all see all of that on the graph. If you look, the graph is turned upside down. You can see that it moved down 3 units. The hardest part to tell on this small graph would be the fact that we have a horizontal stretch, just because it's a little bit harder to notice that when you don't get to see a picture of the entire graph. But if you kind of look at the base there, the bottom one is wider at its base than the one on the top. All right, so again, it says describe how the graph of each function is related and then state the coordinate of the new vertex. So again, this is kind of compiling all of the above. As you look at this, the first one, I'll kind of go over a couple of these, but it says negative 5x squared. So again, it's a reflection, and it's a vertical stretch because of the 5. And because that's all that happens, a reflection and a vertical stretch, our vertex stays at 0, 0. Okay, looking at number 2, the first thing I notice is here. So I know that I have a reflection. The second thing I notice is that I have a +1, so that would go left 1 unit. So a reflection that moves left 1 unit would mean that my new vertex, because of that left movement, would be -1, 0. All right, go ahead and fill the rest of those out. And again, if you have any questions, please check with your teacher, and you can check with your teacher to make sure that you have those correct.